In number 27, we move into rational expressions and we're multiplying. Remember, these work just like fractions, but before we can start multiplying or simplifying, we do need to factor everything that can be factored. So I'm going to rewrite it in factored form. My numerator of my first fraction will definitely break down into two sets of parentheses. My denominator is a difference of squares, so I know that's going to break down. And I see that my numerator in my other fraction has a GCF of a z, so that'll definitely break down. And then the z plus 10 will stay z plus 10. So let's go through and factor everything that we can. So z squared plus 20z plus 100. Factors of 100 that add up to 20 would be 10 and 10. So I'm going to have z plus 10 and z plus 10. Z squared minus 64, difference of squares. So that's going to be z plus 8 and z minus 8. And my numerator of my second fraction, after I pull out the GCF z, I'm left with z plus 8. So now I can go through and cancel. So my z plus 8's cancel. Z plus 10 cancel as well. And it looks like I'm left with, in the numerator, a single z and a z plus 10. And in the denominator, I'm left with a z minus 8. And that would be my final answer. Number 29 is an equation with rational expressions. So we are going to clear fractions, and that way we will be left with an equation that doesn't have any fractions and will be easier to solve. The easiest way to clear fractions is to look at your denominators. So I have a 6 and an x, and I'm going to multiply by 6x over 1. And what you do to one side, you have to do to the other. So I have to multiply both sides by 6x. Now when I do that, on the left, I'm going to have to distribute. When I distribute, 6x times 6 is 36x, and we still have over x. When I distribute to the 5/6, 6x times 5 would be 30x over 6 equals 1 times 6x, which is 6x. Now I can simplify each one of my new fractions. I see that my x's will cancel. So I'm left with just 36, so I cleared that fraction. 30 over 6 is 5, so that fraction's gone. And now all of my fractions have been cleared. Now I'm just going to solve, so I need to get my x's on one side. And that's going to leave me with a single x on the right and 36 on the left. So 36 is my final answer. 31 is a word problem. Martha can rake the leaves in her yard in 4 hours. Her younger brother can do the job in 7 hours. How long will it take them to do the job if they work together? So we're going to use the work principle on this one. It takes Martha 4 hours to do the job. So in 1 hour, she can complete 1/4 of the job. We're going to add to that her younger brother. It would take him 7 hours. So in 1 hour, he could do 1/7 of the job. And that's going to total 1. Now I have 1/4 x plus 1/7 x. Those are like terms. They both have x's, so I can combine them. If you're going to do it longhand, you would have to get common denominators. I would recommend just putting it in your calculator. And when you do that, you're going to get 11/28x equals 1. And now you have to solve this. So you either have to divide both sides by 11/28, which, recall, if you're dividing by a fraction, you're really multiplying by the reciprocal. So I like to just go straight to the reciprocal, or what cancels with 11 over 28? Well, 28 over 11. So since I multiplied the left side by 28 over 11, I got to multiply the right side by the same thing. That's going to leave me with just a single x on the left and 28/11ths on the right. Now, since this is time, we don't usually leave improper fractions when we're talking about time. So I'm going to go ahead and rewrite it into a mixed number. 11 goes into 28 two times, and we would have 6 left over, so 6/11ths. So 2 and 6/11ths hours would be our answer on 31. 33. We have 216 to the 1/3 power. You could do this two ways. You could put it into your calculator exactly like this, 216, and then your exponent. And then since your exponent's a fraction, I would probably surround the 1 divided by 3 or 1/3 with parentheses. It just kind of depends on the calculator. But recall that this is also the same thing as the cubed root of 216. So it doesn't matter how you put it into your calculator. Either way is going to give you the same answer, which is 6. 6 times 6 times 6 is 216. On 35, we are asked to add or subtract, and we have a lot of subtraction going on in this problem. But recall with radicals, they have to be like radicals. And right now, 27, 192, and 147 are not like radicals. But we're going to simplify all three of these first, and then see if they end up being like radicals. So we have to simplify all three of these. Now I know that 27 is the same thing as 3 times 3 times 3, so I tend to go with their prime factorizations. 192, that one I'm not so sure of, so I'm going to break that down. I know 3 will go in. It goes in 64 times, so that's going to actually leave me, I know 64 is 8 times 8. Now, that's not breaking down all the way, but that's okay, because remember I'm going to ring up 2 at a time anyway, so as long as I've got 2 of the same number, it's going to work for me. If I break that all the way down, I would get 2 times 2 times 2 times 2 times 2 times 2, and I would still end up with the same thing. So as long as we have the 8 and the 8 that we can ring up together, we'll be fine. And 147, since I'm seeing 3's, I'm going to try to divide that by 3, and that's 49, which I know is 7 times 7. So then we have 7 times 7 times 3. So when I go through, I'm going to get rid of these now. I don't need that. That was just kind of my scratch work. When I go through and simplify these, remember I can ring up 2 because I'm talking square roots, and those come out in front. So I have the -5 times the 3 and then I still have a square root of 3. Recall that when you have 2, when you're doing square root, for every 2, 1 comes out. So then I have -2, and then I can take a single 8 and its multiplication, 8 out, and I'm left with a square root of 3. And I have a -10, and I can take a 7 out, and I'm left with a square root of 3. So now let's simplify. So I have -15 square root 3, -16 square root 3, and -70 square root 3. Now that they are all square root 3, I can combine all three of them because they're like radicals, so we just look at their coefficients, or the numbers in front, and that's going to get me -15, -16, and -70 is -101, and then I still have my square root 3. So final answer, -101 square root 3. 37 is a foiling this problem. So first, outer, inner, last. So my first terms, square root 5 times square root 6 is square root 30, My outer terms, square root 5 times 7 is 7 square root 5. My inners, negative 2 times square root of 6 is just negative 2 square root 6. And my last terms, negative 2 times 7 would be negative 14. Now remember, you can only combine like radicals, and I don't have any like radicals, and 30 won't break down, so this is actually my final answer. I can't do anything more with that. So square root 30 plus 7 square root 5 minus 2 square root 6 minus 14 would be our final on that one. 39, we have square root of 36 over 7. So I like to give each one of them, the numerator and denominator, their own radical. It's easier for me to see. I know the square root of 36 is 6, but I still have a radical in the denominator, and we do need to simplify and get rid of that. So I'm going to create a perfect square in the denominator by multiplying by the square root of 7. And remember, what you do to the top, you must do to the bottom, because square root of 7 over square root of 7 is the same thing as 1. So this is actually just an equivalent fraction. So I'm going to get 6 square root 7 in the numerator. I get square root of 49 in the denominator. Now I can take the square root of 49 because I've created that perfect square, and that's 7. I have 6 square root 7 in the numerator. And that would be my final answer on 39. 41, we're solving an equation with a radical sign in it. We have q plus 5 equals 2. Whenever you have an equation with a radical, you want to isolate the radical, and then once it's isolated, you square it. What you do one side, you have to do the other, and the reason why we're squaring is because a square and a square root are opposite operations. So they kind of cancel each other out. And I'm left with just q plus 5 equals 4. And now I have this little mini equation to solve. Just subtract 5 from both sides. And I get q equals negative 1. Final answer. 43 is an addition problem with I in it. And we are just going to combine like terms since it is an addition problem. So I have 9 and 5, which would be 14. And I have negative 14 and a plus 8i, so that's going to be plus 4i. And that's it. Recall that I equals the square root of negative 1. We can't combine 4i and 14 because they're not like terms. So that's as far as we can go with that one. Now 45 is a subtraction problem. So we're going to do something similar, but we just have to be careful with our signs. So you can just think of it as you're subtracting everything, or I like to think of it as adding the opposite. And then I just combine my like terms like I did in the previous problem. So I have a 5 and an 8, which is 13. And I have 8i and a minus I, which ends up being 7i. So 13 plus 7i would be my final answer on that one.